So we're going to start today looking at working with functions. So this topic for most schools is the first bit of Year 11. Some schools do it in a bit of a different order. But yeah, it is important. You do need your function stuff again in Year 12. There's a fair bit to functions, I would say, so we will jump straight into that. So the first thing we're going to look at is what is a function. So when you're talking about functions and when you do this at school, you're going to be introduced to two topics or two concepts. So the first concept is a relation and your second concept is a function. And so one of the key things you need to be able to do is to differentiate between a relation and a function. So a relation is a set of ordered points with coordinates x and y, where your x and y variables are related according to a specific rule. So I've got here the example of x squared plus y squared equals 25. And I'm hoping that you recognize that that is the equation of a circle. And so essentially what that's saying is that whatever coordinates we put into that equation, they are going to fit a certain rule so that your x squared plus your y squared will equal to 25, right? Then we have a function, which is a specific type of relation which for only have one y value for any x value. So essentially what that's saying is that when you have x values on your x-axis, each of those x values is only going to be related to one single y value. So let's think about this in terms of the examples that I've got written down there. So with the example for a relation, if you imagine a circle sitting on your coordinate axis, let's say we've got, a point on your x-axis here, that x point is going to have a y point at the top and the bottom of your circle, right? So with that, each of your x points has two y values. Okay, so they are related. There is a rule that dictates that relation, but each of your x values has two y values, so therefore it is not a function, right? Because the thing that differentiates a function from a relation is that your functions are only going to have one y value for each of your x values. Okay, so then looking at that example, y equals x squared, hopefully you recognize that as the equation of a parabola. If you're thinking about your parabola, and you thinking about that in your head, any parabola can be positive, negative, whatever pleases you. If you pick any x value on that coordinate plane, you're seeing it in your head, you'll recognize that each of those x values is only associated with one y value. And that is what makes that a function, okay? If the x values only have one y value. So another example of that would be a cubic function. Each of those x values only has one y value. Straight lines usually are only are functions unless they are vertical lines. Otherwise they are going to be your y values as well, okay? With a function, it's important to recognize that two x values can be associated with the same y value, okay? So essentially, thinking about that parabola again, parabolas are symmetrical, okay? So let's say if we have the function y equals x squared, you're going to have a value of x equals 1, and at that point, y is also going to equal 1. And then you're going to have, when x is equal to negative 1, y will also be equal to 1. And that is still a function, right? So you can have the same y value for two different x values, so long as no single x value has more than one y coordinate. So yeah, that is how you tell the difference between a relation and a function. We're going to look a little bit further about how we can tell the difference between relations and functions when we're looking at graphs as well. So we do something called the vertical straight line test to test whether something is a function or whether it is a relation. Okay, so something else that comes up, sorry, I just remembered this, sometimes in exams is thinking about all functions are relations, but not all relations are functions. Okay, so if we go back to that slide before, we'll see a function is a specific type of relation. okay? And the defining feature is that every x only has one y, okay? So a function is always going to be a relation, but relations are not always functions. Okay, anyway, little side note there, we've got the vertical straight line test, and this is how you can tell whether something is a function or not. So for any graph you've got, this is looking like the graph of sine, and then you've got the graph of a circle over here. So for any graph you've got, if you draw a straight line through the graph at any point, you should only intersect the graph once. Okay, so it's important to recognize that the straight line has to be drawn anywhere. There are some graphs where there'll be points where it only intersects once and other points where it intersects twice. So pretty much if at any point on the graph, if you drew a straight line and you'd intersect the graph twice, it's not a function. Okay, so like this circle here, we've drawn the straight line down this random point here, and we can see that it intersects the graph twice. So essentially what this is representing is that the graph has two y coordinates for this specific x point, because when we draw a straight line, we are essentially drawing this equation, a line with the equation x equals something, okay? And in doing that, drawing a line with x equals something, if it intersects the graph at 2 points, that x has at least two y coordinates. On the converse, if we have a straight line going down our graph and it only intersects once, that means that x equals whatever that line we've made it equal to only intersects the graph once, therefore it only has one y coordinate. And that is how we can tell graphically whether something is a function or not. So you may be asked to do that in an exam to perform the straight line test or to determine whether a graph is a function or not. The other way is once you look at these enough, you will be able to sort of just look at your graphs and pick up whether or not they're going to be functions by just looking, is there any x coordinates that have more than one y coordinate? But that's not something that you need to do right now. That's just as you start to look more and more at functions, you'll be able to start picking up whether something is going to be a function or not. So something important to know, and you will use this from literally the beginning of year 11 to the end of year 12, is about function notation. So you may have been introduced to this in year 10. Some schools do introduce it, some schools don't. It doesn't particularly matter. So if y is independent on the value of x, then we say y is a function of x, which is essentially written as y equals f of x. So this is a little bit tricky to think about. So when we say we have f of x, so just this bit here, this is meaning x being the function, the numerical value or algebraic value that we are substituting in to the function. Okay, so if we've got a function and it's x squared, and we substitute x into that function, we are going to end up with x squared, right? If we have x squared and we have f of 1, we put 1 into that equation, we'll get 1 squared, that's equal to 1. Okay, so we'll have a bit more of a look at an example in a minute, because it's a little bit tricky to get your head around without seeing an example. But essentially, what this means is that our y coordinate is equal to f of x. So our y coordinate is equal to substituting x into the function. So since y is equal to f of x, then f of a is the value of y at the point of the function where your x is equal to a. Okay, so whatever is in these brackets when we're looking at a function, that is what you're substituting into the equation in place of whatever pronumeral is in your function. Usually it is x. I mean, sometimes your equations are going to be given to you as like, a or b or c or anything. Usually it's x. They don't try and confuse you that much, but whatever value, so that can be a number, it can be a letter, is in these brackets, that's what we're substituting in place of our unknown in our original function. So we have come across our first example of example question for today. So if f of x is equal to x squared plus 4x plus 4, find f of a and then f of minus 3. So I will give you guys about 30 seconds or so just to have a go at this question. If you need more time, pause the video and then we'll go through it together. Alrighty, so if you need more time, pause the video here because I'm about to do a big reveal of the answers. So looking at the first part, so part A, our original function is fx equals x squared plus 4x plus 4. When you have a function given to you like this, usually it is fx. Essentially what that means is x is kind of just like your placeholder. So it's saying like, we're not substituting anything in there yet, but when we do substitute things in, we're substituting them in place of this x. So that means when we have f of a, we are putting a in wherever x was in our original function. So then we end up with a squared plus 4a plus 4, right? Because all we've done is substitute a in place of x in that original function. So doing it with pronumerals is typically pretty easy because you're essentially just exactly replacing your x's for whatever pronumeral you've been given, okay? Doing it with numbers is a little bit trickier. So we'll have a look at this example for part B. So we've got f of minus 3, and what that is substituting in minus 3 wherever there was an x in our original equation. So what we do is we do minus 3 squared. Please remember when you're doing these questions, if you are being asked to substitute in a negative value, you must put brackets around them. Otherwise, you're going to end up with the wrong answer when you square it, okay? If you don't put brackets around that squared and you chuck it in your calculator here would spit out -9. But that's not the case here because we need to substitute this whole entity, so this whole -3, where the x is, and in this case, the whole x is being squared, so the whole -3 has to be squared. Right, so you put it in the brackets, square it, and your calculator will spit out 9 for you. Depending on your school, depending on the markers and stuff you get, some markers will actually mark your working as incorrect if you don't have your brackets around your negatives in this sort of situation. So do keep that in mind. We've got -3 all squared plus 4 -3 plus 4. See, in that first line, all we've done is substitute in -3 wherever there was an x in our original equation. Then when you have actual numerical values, perform the equation. So you can either do some mental maths or pop it in your calculator. I would say it's always good to write out every step of your working, just in case something goes wrong. So then you've got -3 all squared is equal to 9. 4 times -3 is equal to -12. Plus 4, and then once you add all of that up, you'll get 1. So therefore, we can say f of -3 is equal to 1. Okay, and so that is how we do simple substitutions using functions, and essentially that's the best example for using function notation and what function notation is useful for.